So in this video, we're going to graph cosine functions. And this video is going to be a shorter video because much of what it is a continuation of my previous video in which we graphed sine functions. There's going to be a lot of similarities. So to graph a regular basic cosine x function, we're going to start with my x and y axes. Like before, we're going to go from negative 2 pi to 2 pi on the x-axis, and we're going to go from negative 1 to 1 on the f of x axis. So in order to graph this properly, I'm going to want a quick table of values here. I'm going to put as my inputs some basic values: 0, pi, pi over 2, 2 pi, negative pi, and negative 2 pi. So again, these are all basic x values in which you're going to want to know the cosine of these values. You just need to memorize them, just know them by heart. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 2 pi is 1. Cosine of negative pi is negative 1. And cosine of negative 2 pi is positive 1. So if I plot these points, we can plot them on my graph here, and we're going to end up connecting the dots. And just like the sine graph, it is going to have a wave feature to it. It's going to be wave-like. So it does look very much like the sine graph, just a matter of where it's located on the axes. So take a look at that. With our sine graph, we started in the center, 0, 0. But with this cosine graph, the point is 0, 1. But like the sine graph, it has this general form. And the key characteristics are going to be A, K, and B. And they represent the same things as the sine graph. So A is the amplitude. K is going to be having to do with the period. So 2 pi over K is the period, which again is, how long it takes to make one complete wave. And B is the phase shift, how far we're going to move left and right. So last thing, before we do some examples, I just want to reiterate the fact of how cosine looks. What I'm calling the center point is at 0, 1. And that's different than sine. Sine's center point was at 0, 0. Alright, so here's an example. Let's first identify our key characteristics. So first, absolute value of 3 is 3. That is the amplitude. Trying to identify what K is. Well, K here is 1. There's no number written there, but it's implied that K is 1. So 2 pi over 1 is 2 pi. That is the period, how long it takes to make one complete wave. And my phase shift is pi over 2 units left. Since it's written as x plus pi over 2, that indicates a shift to the left, pi over 2 units. Alright, so with this in mind, let's try to sketch this. So instead of trying to do it all at once, let's do it in steps here. So I'm going to set up myself with some axes, and you'll see on my y-axis I've actually given myself space to have an amplitude of 3. So on my y-axis I'm going from -3 to +3. Again, that's to give me enough room to apply my amplitude. And on the x-axis we're going to go the traditional -2 pi to +2 pi. So I'm going to draw in everything but the phase shift. So I'm going to draw in a graph that will have an amplitude of 3 and a period of 2 pi. And again, remember where cosine starts. It starts at 0, 1. So if the amplitude is 3, it's going to start at 0, 3. And 2 pi later is going to complete that wave. So I set myself up with a dot at 2 pi, 3. So there is one complete wave. I'm going to repeat myself on the left side of the graph from -2 pi to 0. Another complete wave that happens in a span of 2 pi. And my amplitude is 3. So again, this just took care of the amplitude and the period. That's the red graph. Now I need to apply my phase shift pi/2 units to the left. So on the red graph, I'm kind of putting in some points, and I'm going to move all of those points on the red graph pi/2 units to the left. So all the points on the red graph are going to move pi/2 units to the left. And like I said before in my previous video, you can also think of it as the new graph being parallel to the red graph. So to kind of help guide your pen, to help guide your pencil, make your new graph parallel to the graph before it. So this graph that I've drawn in black has the amplitude of 3, it has the period of 2 pi, and it has the phase shift of pi/2 units to the left. So in black here, this is my final graph. F of x equals 3 cosine parentheses x plus pi/2. Alright, so I got one more example for you for this video. We already did a lot with the sine graphs. Don't need to do too many. So here's one more for you. Amplitude is 1/2. My k value is 2. So when I put 2 pi over 2, that gives me my period, which is pi. For my phase shift, I look inside the parentheses. Inside the parentheses, there's nothing being added to k, or I'm sorry, x. Therefore, b is 0. Therefore, there is no phase shift. There's no left or right movement. The phase shift would come in the parentheses with the x. But what we do have is this 1 out here at the very end, outside the parentheses. So what that is going to do, that's going to shift the entire graph up 1 unit. The +1 represents a vertical transformation of the graph up 1 unit. Alright, so basically if you see a number in the parentheses with the x, that's a left-right movement. any numbers outside the parentheses at the very end is a vertical up or down movement. Okay, so with these characteristics identified, let's try to graph that. So in red here, I'm going to try to graph the amplitude and the period at the same time. So I know my amplitude is half, and I know my period is pi. So it's not going to be quite as tall. It's only going to go half as tall. So I've drawn in my first point here at 0, half. And I know that it completes the wave in a distance of pi. So I can kind of get myself a little bit of a idea of where it ends. So it starts and ends, so the first wave will be complete after pi. Once I kind of have that first wave done, I can fill in some more. Again, each wave completes in a distance of pi, and each wave will have an amplitude of half. So this red graph that I've drawn first has my amplitude and my period shown. Alright, so now let's take care of that +1. So in black here, I'm going to draw my final graph. And before we do that, I just wanted to show you, kind of have a sense of what this amplitude is doing. So when you see graphs, you kind of have a sense of what the amplitude is. In the first one we did, amplitude was 3, so that's a much taller graph. Period was 2 pi, so one wave was completed in a 2 pi distance. With the one we just did, the period was pi, so there's more waves that are going to happen, right? If your period is pi, you're going to see more waves. Okay, so finally let's apply this +1. All the points on the red graph are going to get shifted up 1 unit. So I'm kind of picking some points on my red graph and I'm moving them up 1 unit. So basically I'll be left with another connect the dots kind of action. I'll keep my black graph parallel to my red graph. And I'll get this nice cosine graph as a result. Alright, so there is the final graph in black. I have my amplitude, my period, and my phase shift up all shown there. And like I always tell you to do, check it on either desmos.com or on your graphing calculator. Don't be afraid to use those tools to help you check your answer and see it a little better. So on my iPod here, on my iPad I have kind of the same XY axes. From x I go -2 pi to 2 pi, and I'm looking at a similar graph. On the tablet I see kind of 4 complete waves. Same thing on my paper, I see 4 complete waves. So it looks like we've done it well. Alright, so that is how to graph cosine values or cosine functions, just like sine functions.